So we've talked about the distance formula and how we use Pythagorean theorem with the distance formula, and we take the difference of the x's and the difference of the y's. And so when we partition a directed line segment, we're going to use elements of the distance formula. Okay, and so the components of a directed line segment, AB, are shown below. And you can see that the difference of the x's, so this distance, is the x value component of the ordered pair. And then the difference of the y's is the y value of, or the y component of that directed line segment. Okay, and so again, we're just subtracting the second letter, the second coordinate from the first coordinate to get those components. Okay, so for number 1, we want to find the components of segment PQ. So we are going to take the difference of the x's. Okay, so we have 9 minus 5, and then we're going to take the difference of the y's. And so that's going to be 6 minus 4. And so then when we simplify, 9 minus 5 is 4, 6 minus 4 is 2, not 6. And so that gives us the components of segment PQ. Okay, so a possible route from P to Q is 4 units to the right and 2 units up. That's what that means, okay? So again, the x value is 4, so that means 4 units to the right because right is positive. And then our y value is 2, so that's 2 units up because the y value was positive. All right, so let's take a look at the components of QP. We're going the opposite direction. And so that's why it's called a directed line segment, okay? So because from P to Q, we were going kind of in an upward direction. Now we're going from Q to P, so we're going in a downward direction. We're going from right to left instead of left to right, okay? And so we are just going to subtract those in the other order. So here is our first x value, the 9, and we're going to subtract that from 5. So this time it's 5 minus 9, and then we are going to use 6 as our y sub 1, and then we're going to subtract that from the 4, so it's 4 minus 6 because we're going in the opposite direction. And so we get our components are -4, -2. So that means that our route from Q to P is 4 units to the left and 2 units down. Okay, 4 units to the left and 2 units down. Direction matters. Okay, so in this case, we're not just looking at the length of the segment or anything like that. We're looking at the direction that we're going. Okay. All right, so let's take a look at the next few examples. We want to find the components of each, and we're given a bunch of ordered pairs. And so for each of these, we are going to find the components for that particular ordered pair. And if you want to draw this on a piece of graph paper, that's totally fine. So for number 3, we're going from D to A. Okay, and so we are using D and A, and so we are going to start with our values from A, and so we have 3 minus something, and then we have -6 minus something. Okay, and then our D's are 5 and -1. So we get -2, and then -6 plus 1 is -5. So we would go 2 units to the left and 5 units down. All right, so now let's take a look at the segment BC. So again, we're going to start with the C, and so we have -6 minus something for the x's, and then -2 minus something for the y's, and then we go to B, and we see that the x value is there and the y is there, and so we get -6 minus x for the x component, and -2 minus y for the y component. So in this case, we are not finding an actual value. We're just using the expression. So any of the components that involve the point B are going to be expressions, and all the rest you'll be able to find numerical values. So go ahead and finish 5 through 10, and we'll come back to this. Okay, and so you can see the components of each of those directed line segments. All right, let's take a look at the next part where we're going to fill in this chart with other ways to write these ratios. Okay, so you can see in the first column, we're writing it as one quantity to another quantity. In the next one, we're using the colons to represent the ratios. And then in the final column, we are using fractions, okay? And so if we go across the first row, we're looking at 3 to 4. So we can rewrite that as 3:4. We can also write that as 3/4, okay? So in each of those rows, you're going to rewrite each of the ratios in the appropriate way. All right, so go ahead and complete that chart, and we will come back to it. All right, so you can see the chart filled in, so go ahead and check your answers to make sure they're correct. All right, now we're going to take a look at number 12. If somebody tells you to place the point P so that it partitions the line segment AB using the ratio 3 to 4, that means that AP would be 3 units long while PB would be 4 units long. So draw this situation below. Okay, so if I have, here's my point A, and I got my line segment, here's my point B. So I need to find a place that, a point P, that will be on that line segment AB such that it's going to be 3 units away from A and 4 units away from B. So one thing that I could do is I could actually divide this line segment into a total of 7 units, because that's the total number of units that I could be looking at here. So I've divided my line segment into 7 units, and so I can count 3 away from A, which is going to be, so 1, 2, 3, and then it's going to be 4 away from B. So there is my point P. So out of the entire 7, it's 3 units away from A and 4 units away from B. Okay, let's take a look at number 13. Based on your drawing from number 12, which of the following are true? So if I multiply 4/7 times AB, okay, so remember that AB was 7 units, so I'm going to get a 4 when I multiply that. And PB is 4 units, so that one is correct. All right, if I look at B, I have 3/7 times AB, which is 7. And so when I multiply that, I'm going to get 3, which does equal 3, so B works. If I do 4/3 of AP, remember that AP was 3. And so when I multiply that, I get 4. And the length of PB was 4, so that one works. The length for part D, 3/4 times PB, which is 4. When I multiply that, I get 3. And then AP is 3 units, so that one works. Let's take a look at E. If I do 4 times AP, so 4 times 3 is 12, and I do 3 times PB, well, PB was 4, so that equals 12, so that one's true. And then for part F, I do 4 times AB, which was 7, so that's 28, and I do 7 times PB, which is 4, and that's 28, and so F works also. So all 6 of those end up being true. All right, so you'll only have to come up with one of these statements on your own, but there are many ways to set it up. Okay, so all of those are appropriate equations that can be used when you're looking at directed line segments and partitioning them. All right, so number 14, we want to place the point P so that it partitions the line segment AB using the ratio 2 to 3, or 2/3. Draw this and come up with a statement that compares the sizes. Okay, so I want to draw my line segment AB. Okay. And I want a total number of units that is 5, because 2 plus 3 is 5. So I got 1, 2, 3, 4, 5. There, I got 5 spaces in between my AB, right? And if I want to use the ratio 2 to 3, that means I'm going to go 2 units away from A, which will be 3 units away from B. If I don't end up with 2 units away from A and 3 units away from B, or some equivalent proportion, then I know that I've divided my AB incorrectly. All right, but I have 2 units for AP, and then I have 3 units from P to B. So I know that I'm good. So I have divided my segment up into 5 units. So I can say, okay, well, 2 of those 5 units, okay, so 2/5 of the entire segment AB is going to equal the length of my segment AP. Okay, and you can check that AB is 5 units. So 2/5 of 5 is 2, and AP is 2 units long. Okay, so you come up with a couple more statements for this one. So there are a couple more examples for you of some statements that you could have written. Again, there are at least 3 more statements that you could write. So yours might be a little bit different. All right, let's take a look at the other side. All right, so now we want to actually apply those concepts that we just talked about. So we are given the points A, which is -1, 2, and B, which is 7, 8. And we want to find the coordinates of P on that directed line segment, so going from A to B. Okay, remember that first letter tells you where you're starting, the second letter tells you where you're ending up. And we want it to partition AB in the ratio of 1 to 3. So for every 1 unit of AP, we have 3 units going from P to B. All right, so let's take a look at the distance from A to B, okay? And so your distance horizontally is from -1 to 7, so that's 8 units, right? Because we could do our 7 minus -1, which is 8, okay? And then to get the vertical distance, we're going from 2 to 8, so that's going to give us 6, okay? And then again, if we're looking at that component, it was 8 minus 2, right? Remember those from your distance formula. So we want to divide or partition AB into the ratio of 1 to 3. And so that means that at point P, that triangle that is created is going to be 1/4. The side lengths are going to be 1/4 the side lengths of the larger similar triangle. Okay, and so what we can do is if we want to find point P, we can take 1/4 of 8, okay, and that's going to give us 2, and then we can get 1/4 of 6, and that's going to give us 1 1/2. That's 3 halves, or 1 1/2. And so then from point A, we can add the horizontal distance, which was the 2, because it was 1/4 of 8. So we have -1 plus 2. And then to the 2, the y value, the vertical, we're going to add 1 1/2. And so our new point for P, sorry, not A, for P is going to be 1 and then 3 1/2. Okay, and so we can see, we can check our answer by taking a look and seeing, okay, well, if I add 3/4 of 8, so let's take a look at 3/4 of 8. Okay, if we take 3/4 of 8, that's going to give us 6. And if we take 3/4 of 6, that's going to give us, let's see, 9/2 or 4 1/2. Okay, and so if we were to add that to our P, so here's point P, and we're going to take 1 plus the 6, and then 3 1/2 plus 4 1/2. That's going to give us 7 and then 8, which is point B. So we know that we have partitioned segment AB correctly in the ratio of 1 to 3. All right, let's take a look at number 16. Given the points P, 2, -1, and Q, -9, -6, what are the coordinates of the point on directed line segment PQ that partitions PQ in the ratio 3 to 2? So I like to draw my picture, so I'm going to draw this. Let's see. So we have the point 2, -1. Sounds to be somewhere around there. 2, -1. And then we have -9, -6, which will be somewhere around there. Doesn't have to be perfect. -9, -6. Okay, and then we have our point there. Or I'm sorry, our line segment there. Now keep in mind, we're looking at directed line segment PQ. So we are going from P to Q. And we need to partition it in the ratio of 3 to 2. So if we are 3 units away from P, we need to be 2 units away from Q. Okay, so let's find our lengths. All right, so the horizontal difference there from -9 to 2 is going to be 11. And then the vertical distance from -6 to -1 is going to be 5 units. Okay, and so we know that if we are going from P to Q, then we want to take, well, actually, at this point, it doesn't matter. Going from P to Q tells us where to put the point. Okay, how we're dividing our segment. But at this point, it doesn't matter whether we use the 2 or the 3 to get our new point. So we can say, all right, well, 2/5 of 11 gives us, let's see, 22/5, which is 4 2/5, right? And then, let's see, 2/5 of 5, whoops. 2/5 of 5 is going to give us 2. So then we can add those values to our Q. Okay, and so we had Q was -9 and -6, and we want to add 4 2/5 and 2. So our point, and let's just call this point S. So point S is going to be, oh, let's see, -9 plus 4 gives us -5, plus 2/5 will give us -4 3/5, and then -6 plus 2 gives us -4, and these are in improper fractions, so let's change our x value. So -4 times 5 is 20. Well, let's not do the negative. 4 times 5 is 20 plus 3, so that gives us -23/5, and then we have -4 as the y value, so that is going to be answer choice A. All right, so you go ahead and complete problems 17 through 20.